So, have you ever stopped and wondered how we really know all the things we think we know about people? It's kind of like a detective story, right? Social psychologists are basically the investigators, and the human mind? Well, that's the big mystery. So, today, we're going to crack open their toolkit and see exactly how they separate the facts from the fiction, how they find the real clues behind why we do the things we do. Let's get into it.
All right, here's our game plan. We're going to start by poking some holes in our own common sense. Then we'll see how researchers start gathering the initial clues. After that, we are going to tackle the super important and kind of tricky difference between correlation and causation. Then we'll look at the absolute gold standard for finding the truth. And finally, we'll ask, is the evidence even solid enough to close the case? First things first. We have to talk about our main suspect, which, believe it or not, is our own common sense. I mean, it feels right, it feels obvious, but as you're about to see, our intuition can be a really, really unreliable witness.
Okay, so just think about this for a second. When you see something like, oh, I totally knew that was going to happen, or, well, that's just common sense, what are you actually basing that on? Is it just a gut feeling, or is it real evidence? This is the huge question that social psychology is trying to answer.
Here's the thing. Our brains are absolutely brilliant storytellers. After something happens, they just instantly spin this perfect narrative that makes the whole outcome seem like it was totally inevitable, completely logical, and 100% predictable. But that neat little story, it's almost always written after we already know the ending. And that leads us straight to our main culprit, hindsight bias. You know this one. It's that classic I knew it all along phenomenon. The second you know who won the game or how the election turned out, it's so easy to look back and convince yourself you saw it coming. This bias makes us way too confident in our own intuition, and it's the #1 reason why we need strict scientific methods to get to the actual truth.
Okay, so if we can't always trust our gut, where do we even begin? Well, just like a detective hitting the streets to canvass the neighborhood, psychologists start by gathering clues and just observing the world as it unfolds.
And they've basically got 3 main ways to do this. Observational research is exactly what it sounds like, watching people in their natural element. Archival research is like being a historian. You dig through existing records like old news articles or crime reports looking for patterns. And then you've got surveys, which is all about just asking people questions directly. Now, when it comes to surveys, the sample is absolutely everything. Let's say you want to know what all college students in the country think about something. You can't just ask the people hanging out in your school's coffee shop. That's what we call a convenience sample. It's biased. To do it right, you need a random sample, where every single college student in the country has an equal chance of being picked. That's the only way a small group can give you an accurate picture of the whole population. All right, so once we've gathered all these clues, the next job is to see if we can find any connections. Do 2 things seem to happen together? This is where we step into the really critical and very often misunderstood world of correlation. So correlational research is simply about figuring out if there's a link, an association, between 2 different things. For instance, is there a connection between the amount of ice cream sold and the number of violent crimes? And the answer, believe it or not, is yes, there is. But the why is the part that really matters. And this is how we can actually see those relationships. On the right, you've got a positive correlation. As one thing goes up, the other thing goes up too. On the left, a negative correlation. As one thing goes up, the other goes down. And a score of 0, right in the middle, means there's no relationship whatsoever. And now, we've arrived at it. The single most important rule in all of social psychology, maybe in all of science. If you remember one thing from all of this, please make it this. Correlation does not establish causation. Just because 2 things are related, it doesn't mean one causes the other. So why not? Well, there are a few huge traps. First, there's reverse causation. You might think X is causing Y, when really Y is causing X. But the big one is usually a third variable. Ice cream sales do not cause crime. Hot weather, that's the third variable, causes people to buy more ice cream, and it causes more people to be out and about, which leads to more crime. And finally, you've got this problem called self-selection. Let's say you find that people who read self-help books are less happy. It's probably not that the books are making them unhappy, it's that less happy people are more likely to choose to read those books to begin with. That self-selection creates a totally misleading link. So, if correlation can't tell us what causes what, how do we ever find anything out for sure? Well, we have to force a confession. And in the world of research, the way you get that confession is by running an experiment. This is the gold standard. the real deal. The idea behind an experiment is actually beautiful in its simplicity. All you do is you isolate the one thing you think is the cause, you change it on purpose for one group but not the other, and then you just sit back and measure the effect. So in this picture, the amount of water is the thing we change, and the size of the plant is the effect we measure. Simple as that.
So let's just nail this down. The independent variable is the one the researcher messes with, the one they manipulate. That's the suspected cause. The dependent variable is the outcome, the thing that gets measured. Its value depends on what happened with the independent variable, cause and effect.
And here it is, the secret ingredient that makes the whole thing work: random assignment. Now, don't get this mixed up with random sampling for surveys. This is different. Random assignment is when you take the people you have for your study and you put them into different groups completely by chance, like flipping a coin. This makes sure that on average, your groups are pretty much identical before you even start. This is the magic key that lets experiments prove cause and effect. Okay, we've done our experiment. We have a result. But is the case really closed? Not quite yet. Before we can be sure, we have to check that our evidence is actually solid, that it's trustworthy, and crucially, that we got it ethically. First step is reliability. Think of it like this target. A reliable measurement is all about consistency. It hits the same spot over and over and over again. Now, that doesn't necessarily mean it's the right spot, but you can count on it to be consistent. But of course, being consistent isn't enough. You also need validity. This is all about accuracy. Are you actually hitting the bullseye you were aiming for? Are you measuring what you think you're measuring? See, a measurement can be reliable, but not valid. You could hit the same wrong spot every time. But for it to be good science, you absolutely have to have both.
And last, but definitely not least, all research has to be ethical. This is non-negotiable, and there are layers of protection. First, something called an Institutional Review Board, or IRB, has to approve every single study before it begins to protect people from harm. Then, participants have to give informed consent, meaning they have to know what they're getting into before they agree. And finally, after it's all over, the researchers have to debrief everyone, explaining the real purpose of the study.
So you see, understanding how we know something is every bit as important as what we know. So the next time you hear some new fact about human behavior, you'll have the tools to be a detective. You can ask, is that just a correlation? Was it a real experiment? Was the evidence actually solid? Go ahead, start questioning.